In this video, I would like to go through some additional exercises that are so to say on paper that should help to solidify the understanding of pointers and references. The exercises that I have here, they're quite similar to typical exam questions on those topics. What we are told here is we have 6 variables, a through f, and once those been declared and initialized, they will be stored at those addresses in memory. And for simplicity, all addresses differ from each other by 1000 in hex. Then we are given some code, and here first the variables are declared and initialized. Then some changes are made to them. And finally we have some print statements, and we're being asked to say, well, what would those print statements print to the console? So the best way to approach these questions is to draw yourself a diagram and update this diagram as you work your way through the code. So based on line, okay, so I'll do this in blue. Based on line 2, we have the initialization of A, and A is initialized to 5. On the next line, likewise, B is initialized to 8. On line 4, we have a reference given the ampersand, and it's initialized to refer to A. So I'll just say that C is equals to A. And then on line 5, we have a pointer. We have the star. And the pointer D is initialized to the address of A. So we'll have D. And it's going to point to A. And then the address of A is 1000. So we're going to store 1000 into D. So 1000 is going to be the value of D. On the next line, we have the same thing with E. And E is going to be initialized to the address of B. So this here is going to be X 2000. And E is going to point to B. Finally, on the last line, we have a double pointer F, and that one is initialized with the address of D. So I'll put F here. And then the address of D is 4000. And so this here points to D, and this is F. Okay, so we have gone through the declarations and initializations. Now, on line 9, we say that D is now equals to E. So this means that D is now going to have 2000 here, because that's what E is. And it's going to now point to B, because 2000 is the address of B. On line 10, we are assigning E to be the address of A. So the address of A is 1000. And now E no longer points to B, it's going to point to A. On line 11, we are assigning F to be the address of E. So the address of E is 5000. And F no longer points to D, it points to E. And on line 12, we have a double dereference of F that we set that equal to 4. So what that means is that we would follow F through the first dereference, so through here, and then through the second reference, and that brings us to A, and then we would reset this value to 4. So this becomes 4. So then the question is, well, what gets printed on all of those lines? Well, the value of A, we know that's 4. B hasn't changed, so that is 8. C, well, that's a reference to A, so that's 4. The dereference of D, so dereference of D, we follow that to B. So that, maybe I'll just write on this side. So that's going to be 8 again. So that's 8. And then we dereference E, and that's going to point over here. So that's a 4. And then once we dereference once we dereference F, that points to E. So this is going to be X 1000. And then if we double dereference F, that's going to point, like we followed it here, to A. So that's going to be 4. So this is how you would do an exercise like this. If you are doing this for practice, you could copy the exercise into your text editor and then compile and run things just to check that you got the correct answers. So I have done this here, and I'll compile and run this. And let's see, so we have 4, 8, 4, 8, 4, and 4 here. And that's what we had here, 4, 8, 4, 8, and then 4 and 4 here. Of course, the address that we're looking for here is not going to be 1000. It's going to be whatever this computer that I'm on decided to use. So if you do want to check to see if that address makes sense, what we were looking for here was the address of A. That's what X1000 is. So we can just print the address of A here at the beginning and see if those match up. So I'll recompile this, and we see that the address we're looking for here does match up with the address of A. So we should be okay here. So let's work through the next problem. Here we of course have to start from main, and we'll draw ourselves a new diagram. So we have A, and this is initialized to 3. And then we have B, and this is initialized to 5. And then C is this pointer that's initialized with the address of B. And the address of B is still 2000. So this is C, and it points to B. And then we make the call to the mystery2 function. And the function takes an int by reference, a pointer, and another pointer by reference. So what I sort of like to do is I first of all like to write over here, what are those things? So this int by reference, that's A. Then this pointer is the address of B. And then this one here, this is, well, it's C. And it's still equal to the address of B. Okay, so on this line we have X multiplied by 10, and X is passed in by reference, and that's A, so that would change this to 30. On the next line, we dereference Y, and we set that to be equal to whatever Y was plus X. And Y points to B, and b was 5, and x is now 30, and we dereference a pointer, so we do follow the address to the memory location where it points to. So we do go to b. So this 5 here is going to change into 35. So this is now 35. And then on line 4, we set z, which is whatever this is, to be the address of x. And this pointer is passed in by reference, so the changes are going to have an effect back in main. So we now have c point to a, and this here is going to be 1000. Because that's the address of a. So then we go through the print statements. So what is the value of a? Well, it's 30. What is the value of b? That is 35. What is the value of c? Well, that is 1000. And what is the value of the dereference c? So this now points to a. So that is going to be, once again, 30. Okay, so that's how this problem works out. So we can check our work. So I have the code here. And I know that I'm expecting the address of a for this line. So I have put a print statement here that checks what the address of a is anyway. So we'll compile, so I'll clear this. We'll compile and run things. And we see that we do have 30, 35, and 30, just like we predicted over here. And then the values here match up, that the addresses here are the same. So this value here is indeed the address of a. Okay, so let's work through the last problem. We will once again start in main. And here we have a, which is initialized to 10. And then we have pointer b, which is initialized with the address of a, which is x 1000. So this is b, and it points to a. And then we make the call to the mystery3 function, which accepts an int by value, and then accepts a pointer. And those happen to be just a and b. So what happens in mystery? Well, on the first line, x is added to itself, and x is 10, so this becomes here 20. So this is the local value of x, because x is just passed by value, so we haven't changed anything outside of mystery3 yet. Then in here, we take this local value of x and we subtract 2, and we save that into wherever y points to. Well, x minus 2 is 18, and then we have to follow what y points to, which points back to here, back to a in main. So this becomes 18. And then we return x, and this local x is 20. So that's going to be the value of c once it returns. So then the value, going through the print statements, the value of a, well, that is 18. The value of b, that's the address of a, so that's 1000. And then the dereferenced value of b, that points to here, so that is 18. And then the value of c, that is 20. Okay, so let's check our work. We are here in code, and I have added this line to print the address of A because that's what I'm looking for on this line here. So we'll compile and run things. And we do see that things match up. We have 18, 18, and 20. And the addresses in here match up as well. So that is sort of the strategy of how to work through those type of questions.